Welcome back, everyone, to another explainer. Today, we're tackling something literally every single professional faces at some point, those messy, tangled up problems. You know the ones, right? The issues that keep you up at night with like a dozen overlapping causes. Well, today we're exploring a fascinating operational framework from our source material called the Logic Tree Creation Script. Let's see if we can take all that chaos and cleave it into absolute clarity. Okay, let's dive right into this. Think about how most people react when a key metric suddenly drops or a major project goes off the rails. What usually happens? Total, absolute panic. Managers lock themselves in a conference room and just start guessing. They're throwing out a dozen different theories, trying to whiteboard their way out of this complex maze. It's a completely scattershot approach. But here's the thing. To actually solve a messy problem, you need a scalpel, not a sledgehammer. You need a systematic way to dissect the issue so you can actually fix it. And that brings us to the uncompromising rule of this entire methodology, straight from our source material. Force clarity first, no blending. It's absolutely crucial. We cannot just blend multiple issues together and hope to solve them all at once. Actually, scratch that. If you try to fix two abstract things at the exact same time, you'll end up fixing absolutely nothing. This script demands rigorous analytical focus right from the very first step. To get us there, this script breaks down into 4 highly structured logical phases. 1, defining the core problem. 2, mapping the MEIS branches. 3, prioritizing and testing hypotheses. And 4, execution and final action plan. Let's get into it.
Phase 1, defining the core problem.
So before we can even look for solutions or start building out a logic tree, we have to isolate the exact seed of the issue in a single sentence. Notice the stark contrast here between how amateurs and professionals define a problem. On one hand, we have a really vague symptom. Things are bad, or sales are down. You can't fix that. But on the other hand, look at our clear, measurable case study. Dealer funding is down 18% this month. The specific script you absolutely must use is, the problem I'm trying to solve is, and then fill in the blank. Notice how the clear version introduces a strict time frame and a measurable outcome? That's a real game changer.
And this brilliantly illustrates the very next step, finding your core outcome equation. Most business problems actually sit inside a simple mathematical or causal equation. You really have to ask yourself, what are the specific drivers of this outcome? For example, if you're looking at revenue, it's volume times conversion times value. For a case study on fundings, it's applications times the approval rate times STIP completion. Or if you're looking at profit, well, it's revenue minus costs. The big takeaway here, if you can't look at your problem and find the causal equation that governs it, you simply don't understand the system yet. You've got to map the math before you map the solution.
Phase 2, mapping the MEIS branches. Now, this is where we make our first clean, precise cut into the data to separate the drivers. To do this, we use a really powerful concept called MEIS. That stands for mutually exclusive, collectively exhaustive. In plain terms, this means we need to find 3 to 5 non-overlapping drivers that fully 100% explain the outcome. The absolute golden rule here is that there can be no overlap and absolutely zero vague categories. If you use a giant bucket like operations or the market, you are instantly muddying the waters. Each bucket must be independently measurable. If it's not, toss it out and start over. So how does this all build into the anatomy of our logic tree? Well, step 1 is identifying those 3 to 5 first-level drivers using our equation. Step 2 is to cleave again, going even deeper into second-level causes. For every single branch, you must ask the script, what specifically causes this driver to rise or fall? What inputs feed this? What behaviors influence it? What systems control it? And then step 3, you stress test the entire structure. Let's apply this cleaving process directly to our case study. We already know dealer funding is down. Let's say we look at our equation and realize the approval rate is the specific driver that has dropped. We ask, what specifically causes the approval rate to fall, and we cleave it into subcauses. Was there a shift in the credit mix? Maybe there were underwriting policy changes. Are we seeing more incomplete applications? Or actually, is there a variance in dealer quality? See what we did there? We've taken this massive, scary problem and isolated exact actionable categories. But hold on, before we act, we have to ask a critical question. Do any of these overlap or leave gaps? This is your stress test. Would 2 of our branches explain the exact same issue? Is there a missing category that just doesn't fit anywhere? Are any of our buckets just lazy catch-alls? This is the crucial checkpoint where honestly, most people just skip ahead. And because they skip it, their tree becomes a messy, useless failure. You have to fix your tree until every single issue fits into exactly one place.
Phase 3, prioritizing and testing hypotheses. Now that we have a perfectly structured tree, we're officially shifting from structuring the problem to rapid action. So the crucial point is that we cannot tackle every single branch of the tree all at once. We have to rank each branch by impact and controllability. We look at each one and ask, is it high, medium, or low impact, and is it high, medium, or low control? The script you need to run through your head is which branch explains the largest share of the problem and is most controllable. For sure, we are only going to focus our time and energy on the top right quadrant, the areas where we have high impact and high control. Just ignore the rest for now. Once we've isolated our top priority branch, we stop analyzing and we start testing. We convert that top branch into a hypothesis. We take a broad, pretty useless guess, like something is wrong with credit, and we force it into a falsifiable statement, like approval rate dropped due to stricter credit filters. The script here is simple. If this branch is the main cause, what must be true? Think about it. If it's stricter credit filters, certain specific things absolutely must be true in the real world. Phase 4, execution and final action plan. This is the payoff, folks. This is where we stop theorizing entirely and start verifying with hard data, assigning strict accountability. To verify our hypothesis, we ask our ultimate reality check script. What data or observation would confirm or reject this? Because let's be real, no logic tree is useful without verification. If our hypothesis is about credit filters or dealer quality, what exactly do we check? Well, we might compare dealer submission frequency or pull the approval rate by dealer tier. Maybe look at the application completeness rate or time to fund trends. We have to find the exact data signals that prove or disprove our branch. Once the data confirms our hypothesis, we demand execution. You spell out the exact requirements. The final script you use is who owns each branch and what is the next concrete action. Every single actionable branch of your tree absolutely must have 3 things attached to it: a specific owner, a specific metric to track progress, and the immediate next step. Without these 3 things, you literally just have a pretty drawing on a whiteboard. When you step back, your final output structure is just a thing of beauty. It flows flawlessly from an abstract issue right down to assigned execution. You start with the exact problem. You map the MEIS drivers. You cleave into subcauses. You select the highest impact, highest control branch to form a hypothesis. Then you validate it with data, and you assign an action. It's a seamless, undeniable chain of logic. I absolutely love this line from the source material. Now the tree becomes execution. That's the entire goal of this explainer. We didn't build a tree just to neatly organize our thoughts. We built the tree to carve out a clear, undeniable path to fixing the problem. We forced clarity, we completely eliminated the blending of issues, and we engineered a true operational mandate. So, I'm going to leave you with this final thought to chew on as you head back to your daily operations. Look at the biggest, most complicated issue sitting on your plate right now. You know, the one that feels completely overwhelming. Stop guessing, stop blending, grab a piece of paper, write down the outcome equation, and ask yourself, what messy problem will you cleave into clarity today? Thank you so much for learning with me on this explainer, and I really can't wait to see the incredible logic trees you built. Keep analyzing, and I'll catch you next time.